Hello everybody, I'm Marco Dambos and today we're going to see how to do an array tail system or an array elements chain system. I'm not sure about the name, so actually you can help me to give a name on the system. I'm not sure which one is the most correct one, but the main idea is very simple. So we are going to have one target, one goal is in this case is this transform, and we are going to create this chain based by a number of element that we can define, I call segment, and the length of this segment. The system per se, what does it do is going to follow up this target and every elements that are going to follow up the previous object in front of them. And you can see you have this sort of like snake-like or train-like chain system where every element follow each other. And of course, I mentioned like we can change the number of element or the length of the element. Yeah, and we have this option here. As a small plus of the system, we are going to let's say as a small plus, we are going to even add a collision system with a mesh. This give you like this sort of like slide system. If you see here, is collide with a mesh, create this sort of effects. Yeah, and that is the system. So what I thought, it was like, I thought that this was a good exercise, a good example to show you how to use iterate in Bifrost and how to interact with previous computation of every Bifrost node evaluation. So what we are going to do, we are going to storage our computation in one attribute plugs, and we're going to use for the next evaluation. And that's it actually. So let's jump in immediately so we can see how the system works. So the base concept, the base idea is very simple. So we are going to have our target. We are going to have our element. What we want to do is, from our target, we want to create a vector that defines the direction from our goal, our target, to our element. We are going to find the new position of our element, and the new position is based on the length of the segment, right? So we are going to normalize this vector, multiply by the length, for example. In this way, we are find the new position of my element 0. And we do this process, we're going to do this process for every element of our chain. So that is where the iteration comes from. So for example, if I have element 1 on iteration, or the second iteration of my chain, of my loop, sorry, we are going to create this vector for my goal. My goal is not anymore target, it's not here, but it's gonna be my element, the new position of my element is 0. So we're going to create this vector. At the same, we do the same thing. So normalized, multiplied by the length, and we find the new element 1. And we do this for all the chain. So now that we saw the base, let's jump in on and do it. So first things first, let's create our goal, our target. It's going to be this transform. Let's create our Bifrost node. So probably in some of my previous video, not all the time, but some of my previous video, you show me, you see me using matrix to SRT to get some value of a matrix. That actually it's a valuable method. The thing is, matrix to SRT, the same way of the composed matrix, is actually there's like a few computations inside that node, because you need to get a matrix 4x4 and find the rotation, scale, share value. And translation as well, but translation we're going to see is the easy one. So you do this computation even when you don't need it. In case of when you want to have just a position, so in case of transition or position in space, we know that in a matrix 4x4, the last row is our position in space, so we can just use that one. In this case, the easy way is just create a value node. This is going to be our matrix 4x4. We just connect because this is going to be our input target, and when we connect, so now we have access to the matrix %. So if you can see, we have all the rows 0, 1, 2, 3, and like I say, we know that the row 4, the fourth row, is our position. Just remember, the matrix is a 4x4, so every row has a 4 element, x, y, z, and w. So what we need to transform our vector 4 to vector 3. So we can plug our row and just. So this is going to be our target, and this is our position. So what we measure, so the other things we need is we want the number of segments that we need. So that is going to be an integer. There you go. segment. Actually, let's call segment number. I do prefer it that way. And we want to have the length as well. So that is already a float, so it's fine. Segment. Just remember when you declare the default value is 0, so just let's put this on 1. Of course, you can write a condition or comp, then automatically get the minimum value to 1 or whatever you think is the proper one. So let's connect our target to our system target. Here we go. There you go. It's done. Next time. I'm joking. So now, yeah, we have our target, connect to our Bifrost node, etc., etc. So let's jump with the first steps. So this system actually it can be worked on even on this level. So we can actually now create an input and output that are let's say connect with each other, interact with each other on this level. The thing is, every plugin you create in this input, they're going to be exposed, and we don't want to expose any of these attributes, and it's just for internal computation. So to avoid that one, we're going to create a compound. This is gonna be actually where we do all our stuff. So you can call it like evil solver. It doesn't have a proper name. I call it solver because it's where we solve stuff. But you know, it's just a name. So we need our target. We need our elements, and we need our length. And we don't need this anymore, by the way. Okay, so we almost have every element. We can jump in. So the first things we need to think about it, we want to have the position of our array. So we want to have actually an array, but we don't have at the moment. At the moment we have like a zero information at all. So let's start creating an array, and I use the resets array. I think is I find the more comfortable for these things. So let's get our number of segment as a new sites. Is the new sets of array. So doesn't matter how many elements it has of my array at the moment. We are going to define with the our segment number, and in case an element is missing, we are going to create in this way. So the default value is gonna be 000, but we can change it. So that is the thing. So that is the starting value at the moment. We can even expose it to change dynamically. You can play with these kind of things. So now we have an array of element on position 000. This is gonna be our out. Okay, so we have our element of position. So what we kind of mentioned, we want to interact with the previous position. So every time we move something, we want to start this one as a previous position. So let's create a new input here. We can even plug this one. Actually this way. It's so we want to have an array, tree array, okay? And so this is gonna be our input. These our element preview position. So what we want to somehow connect this element out position with this element previous position. If you right click, you can go set port feedback and select the output we want to, and you can see now this icon in our input and our output. So this means now then on the next iteration, if this value has something, of course, it's going to be used this array. So like I say, this now is my previous element with all our chain array position or our chain position. So that is our start point. So we want to connect this one to our arrays. In this way, if you already have all the position, we don't need to change anything on our array sites. We want to change the arrays only if just to shrink or increase the value of elements in our chain. So, and that is actually going to be our output, and we have now our system. Some other things I want to add it. I want to create a value here. Of course. So this value is going to be vector 3 array. Go. So the reason why I do this one, I use this one more as a sort of like anchor point, because we are going to add something in the middle during the process, and I don't want to all the time change multiple outputs, so I just do once and that's it. So now then we have our array and have our list. Just let's start to draw something. So construct string, and our strands are our point position. Terminal. Let's go as diagnostic, and we won't even draw our elements. So like create a sphere, you whatever you want. Okay, one of the things I probably say this kind of multiple times when I talk about Bifrost. One of the good things about Bifrost is Bifrost already manage internal loops. So if you see the position here, this is a single element. So if I create now, it's gonna be just one sphere. Actually, the radius is a little bit too big. But the moment we connect a single value with an array, like this one, this is automatically going to do internal iteration and create all the sphere that we have per element. So we don't need to do any loop or iterator in this kind of situation. We want to create like a loop like the one that we are going to do now, only if we want to interact and do something inside the loop. Okay, so now we have our output. We draw and we output some value. We can check these things later. So just jump back on our solver. So what we need in our solver is, so we create an array, we can output, and we pass the new position as a previous position. We almost have everything. So let's start now to iterate. So let's create the iterate node. What we need is, we want to define our target. We want to pass all the element, and we want to pass the length of our elements. And of course, I made the mistakes. Here we go. Here. And our length here. Not sure what's happened today, but I have very bad aiming. Okay, so I want to just start to show you what we have here. So we have a target. We have an array that these are actually our elements, right? And we have our length. Inside the iteration, we want to interact with one element at a time. We don't want to have an array. So one thing that we can do it with right click, we can set iterator target as true, and it's going to change with this icon here. And now if you see the elements is not anymore an array, it's just one single value. So externally it's still an array, but when you go internally, our for loop is just single array. This is because this one now, this node, the iterate node now, is looping inside all these elements one by one. And we can even put this one as an output. It's going to be our elements output. If you see, is a single element, and even here is a single element. But so we input an array. So we want to still have a back an array, because even our element out position is still an array. And we are going to do the same things we did for the input. So right click, port iterator is become true. If you see the icon now change, and if you go aside, this become an array. The reason is very simple. This is gonna sort of like list append inside the list in Python. So we are going to append every iteration. We are going to append the element and create a list from this for loop. So now that we have every element we got here, we just need to do what we draw here. So we want to get a subtract node, and we want to subtract our element position with our target. We want to, actually we can even do this one. Let's go on this. We want to normalize the vector. We want to multiply by the length. Here you go. Actually, let's do like this. Okay. So if you see now, the element is going almost, I don't want to say the opposite part, but actually what it's doing is aiming our target. It's just is localized on the center, but is localized, but is aiming properly. So what we're missing now is, we're missing a couple of things, but let's start. First of all, we want then that vector is on our target position. So we just get the target, put there, and if you see everything works fine. This is not, we is missing a couple of things. I just want to show you one thing. So actually, so if you see the length is working with the length, so we increase the length, everything works fine. And even if we change the number, say 5, everything works kind of fine. But if you notice, the position of all the our elements are the same. And the reason is we are using a static target, so the target is always our goal. But if you remember what we say, we want that the target is going to change element by element. So one way to do it, or the way that I like to do it, I just create a new one. This is going to be our new target. And now we can set this new target as a feedback here. So set post state new target. And so now what's happening is just get the when we compute this in this loop, the next iteration is the new target as actual target. And this way we are going to have our chain. It's good. I want to show you a couple of other things. So let's increment other 5 element. So we're going to 10. If you see, they're aiming to the 0, 0, 0. So that aiming is actually this node here. I want to show you. So for example, if I change this one to 10, 10, 10. Now if I go to 2, so if I now increment from 2 to 10, if you see, now it's not aiming anymore to 0, 0, but to the vector 10, 10, 10. So you can use this one even dynamically if you want to. So you can play with this value and find a way to where to aiming when you create an element that they don't really exist. So another things that we need to implement it is then max iteration. So at the moment the max iteration is 10. So if I, for example, I create now 20, nothing happened because the max iteration is 10. One way you can say that, oh no, you know what, you want want to have 100, so you can always give like the maximum value, value that is maximum, and this maybe it's okay if you want to have some sort of like limitation. Another way is you can connect the segment number as a max iteration, so that is become like dynamically now, and you know when you set this number, that is the max iteration you're going to do. You can even clump. So I prefer this one because in this way our max iteration is never more than what we need. But at the same time you can clump it with our function, etc. like that. You can manage it like whatever you want. You can have as an input, you can have as a starting number, etc, etc, etc. So actually now let's just make this one a little bit shorter. So we have everything we need. So we have our chain of an element with a proper the segment. This is just missing a couple of things we want to see. So if you see actually our element, they start to our element -1. So they not start from the target, but from one element below. You can fix in a couple of ways. I want to show you this one. So you can create actually here a build array outside everything. This build array is kind of work as sort of like insert or append. You can build an array between elements, and what we want to do, we want just add our target as a first element and all our list as the rest. So now when we plug here you go. So we have actually now our strand and ours free create from 0. Another thing that I want to show you, if you're going to set the solver, at the moment I'm using the length as the length per element, right? So this can be okay, depends what you want. So for example here, if I change the, let's do this one to 10. If I change the length to 2, this we just literally change the length of our chain. So the length of our chain is based of number of element multiplied by total length. But we can even use this length as a total length of our system, and to do so we can just create like a divide node. We can connect our total length with our segment number. You can, I'll show you in this way. So you can divide by segment number, and you can just plug this one to the segment length. Now you see that is red because this divide is not, Bifrost is not able to compute this one. So you cannot compute two different elements like float and integer. So you need to have a node called toFloat. In this way you can transform this integer number in a float. number, and when it's a connect, everything works fine. So now actually my length number, my length is actually the length of all the systems. So for example, let's put 10. And that is actually interesting because now I can change the number of my element here, and I know then I'm not going to change the length of my chain. So I can kind of like, at the moment I'm fixing the length of my chain. Doesn't matter how many elements I'm going to create. We are almost done. I want to show you another couple of things. So we output a value. Actually, we output an array of value, and these array of values are the position of my elements. So in this way, doing this one is mean I can create, I can connect something to our chain. So for example, let's connect a cube. So let's find the element out position. If you say this is an array and this is all the array that we're using, let's connect to element 5. We just get this one, and we can connect to translate. So at the moment my cube is connected to translate. But this is kind of a static value, and it can be changed, etc. We can even add another option, then is with get from array. So we can get the array, we can output, actually input, sorry, the index, and this is gonna be our output. We can call index element position. Doing this way, we can actually query which index we want to have it as output, and so it's kind of like as a more dynamic system, and I think it's fine, very interesting. So index element position, then we get the position, connect to translate. So now it's going to the 0 because we create an index 0, but you can now move this one, I see, is moving through the chain index by index. So you can change, you can choose where, and you can actually create dynamic. So it's I say it's everything for today, for this video. I'm going at this, so we can call this on part 1, and we're going to do a very quick video as a part 2 where we are going to implement then the collision system with the mesh. Thank you very much for watching, and catch you next time. Marco.